Uh, I'll start solving assignment questions from 310. I guess lots of people are joining. I guess we'll wait till 310 and then after that I'll start.
I'm not, I देखिए मैं लाइन नहीं कर रहा हूँ, मैं डायरेक्टली सॉरी सब कि आपने मुझे सुनाई कि all these things that खाला जान तो आप जो क्लेम कर रही है ना उसका कोई बेस नहीं है ना उसका सर नो 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 आप एक मिनट एक मिनट एक मिनट don't ever talk sometimes after getting a monitor you have to.
Ferrari. Or the AFC and
to put any kind of thing. And
Okay, I guess I'll start sharing my screen. We'll solve assignment 1 today. I have posted the link in chat. You can solve things simultaneously with me. Okay. So yeah, it's just preferable that if everyone joins before 3:10, or else I'll be getting these notifications and everyone gets disturbed. Yeah. Okay, so I didn't introduce myself properly last time. So basically, I'm Bhargav Pawan, and I have done my BTech from NIT Nagpur, and I have done my masters from IIT Bombay, and I'm currently in PhD second year at IIT Bombay, and I am teaching assistant of this particular NPTEL course as a PMRF student. So it's one of my PMRF duties, and I think I have posted my uh, contact number last time, and some of you have contacted me. Yeah. So, mostly we have another 2 weeks. Include this one, it's 3 weeks. So we'll be doing assignment 1, 2, 3, 4. Hopefully in these 3 weeks. Yeah. I hope you're going through the lectures and everything so that you can follow through the assignment. Yeah, sorry, I think I had a network issue. Yeah, so what I was saying, we'll be solving assignments of Laplace transforms every week, and I'm doing this as my PMRF teaching assistant duty, and currently a PhD student at IIT Bombay. Okay. Okay, I guess I'll just stop taking people from now. Okay, we'll start from question one. So we have to determine which of the following Riemann integrals exist. It's kind of simple question, just elementary integration. So it's question one. Uh, Integral 0 to infinity cos t dt. Integral of cos is sin t, right? Infinity to 0. Because sin infinity doesn't make any sense, does not make any sense. So this integral is improper integral. Okay. I mean, this integral doesn't exist. Sorry, uh, not. So there are some improper integral that exist. This doesn't exist. Next is half to infinity t power minus 5 by 2. Half to infinity t power minus 5 by 2, which is t power minus 3 by 2 by minus 3 by 2. Integral half to infinity, which is nothing but 2 by 3 times 1 by 2 whole power minus 3 by 2, which is nothing but 2 by 3 whole power 2 power 3 by 2. So this thing exists. So it's a proper, this exists as an improper Riemann integral. Next, integral 0 to infinity power minus t square dt. So minus t square dt. So solving this is not trivial. So we define I1 equals. Uh, does anyone know how to solve this particular integral? I mean, how to compute this integral? Any answers?
By using gamma function.
Yeah, gamma function is one way. Okay. Any other approaches? Yeah, fine. Gamma function is one way. One more way is define 0 to infinity e power minus x square dx as I1, and I2 is equals to integral 0 to infinity e power minus y square dy. Right. Note that I1 is equals to I2. I1 is equals to I2 is equals to I. So implies I square is equals to I1 into I2, which is equals to integral 0 to infinity integral 0 to infinity e power minus x square plus. Okay, I am audible and my screen is visible, right? Dr. Vasant Kumar, can you answer? Hello.
Just just before it was visible. Now it is not
Okay, okay,
visible.
fine. It's visible right now, right?
Yeah, now it is visible.
Okay. So,
Yeah, you are audible. Nothing
okay,
to.
okay, okay. Thank you, Doctor. Okay, you have this particular thing. So implies I square is equals to integral 0 to infinity integral 0 to infinity e power minus x square plus y square dx dy. Now you use coordination. I mean, you change this integral from Cartesian to polar. So you basically have your integral domain extending like this. So it is basically integral 0 to infinity. R is from 0 to infinity, whereas theta is from 0 to pi by 2. 0 to pi by 2 e power minus r square dx dy becomes r dr d theta, which is equals to integral 0 to pi by 2 uh, d theta into integral 0 to infinity e power minus r square r dr. Implies I square equals pi by 2 times uh, integral 0 to infinity e power minus r square into dr square by 2, right? Which is equals to pi by 4 times. Just take r square as t, 0 to infinity e power minus t into dt, so which is equals to pi by 4 into 1 minus e power minus t. T tends to infinity. So, sorry, this is pi by 4, right? Which is pi by 4. Implies I square equals pi by 4 implies I is equals to root pi by. So even this integral exists as improper Riemann integral. Okay. So next question. I hope you can check. Okay, I'll check this. Okay, integral 1 to infinity 1 by t dt. And integral 1 to infinity. Is my screen visible or not? Uh, I don't understand how. Okay, now is it visible? You should be seeing that infinite this thing right now. Dr. Vasant Kumar, are you able to see my screen? And
Yeah.
okay, okay, thank you. So integral 1 to infinity t dt is basically log mod t
Is it
from 1 to
I think previously it was discontinued. Can you explain once again?
from which point?
Excuse me, sir.
Yeah. From which point? Uh,
From the last, yeah, from changing coordinates to polar coordinates.
okay, till here it was fine, right?
Yeah, everything was fine after that.
Okay, I'll start. So basically we have this particular integral I square is equals to what? Integral 0 to infinity integral 0 to infinity e power minus x square plus y square into dx dy. Now this is in Cartesian, right? Now, so with some elementary multivariable calculus, you have this identity r dr d theta. Dx into dy will become r dr d theta. This requires some derivation. If you are interested in understanding how we get into this particular transformation, uh, I can tell you. Okay, okay. Let's. So till now we understand this. So there is something. I mean, if I try to prove this, will get into some unnecessary multivariable calculus thing right now, where we have to compute the Jacobian matrix and then compute the equivalent of dx dy. Uh, okay, I'll just give a sketch of. So we have this integral, you have to compute this. So in Cartesian, this is the domain 0 to infinity, 0 to infinity, x tends from 0 to infinity and y tends from 0 to infinity. Now in polar sense, what will the limits be? This is 0, this is pi by 2. So 0 say pi by 2 angle is varying, and radius is varying from 0 to infinity as usual. So this is e power x square plus y square is r square. Dx dy is r dr d theta. These are some identities that I am directly using from the knowledge of multivariable calculus. But these are some elementary transformations that all people know. You might have done it in your M1, M2, M3. Okay, so you get this. So now you can just separate out your integrals 0 to pi by 2 d theta into integral 0 to infinity e power minus r square r dr, which is okay. Okay, so this happens, and now this is basically pi by 2 in integral 0 to pi by 2 d theta is pi by 2, whereas this particular integral becomes 0 to infinity e power minus r square d r square by 2, right? Which is nothing but pi by 4 times you take r square as some t, 0 to e power minus t dt, which is nothing but pi by 4 times 1 minus e power minus infinity. So which is pi by 4. So your I square is equals to pi by 4, implies I is root pi by 4. Now main question is, how do we get dx dy is equals to r dr d theta? So this has to be something like a Jacobian transformation. I'll just check if I remember things. So you use the transformation x is equals to r cos theta. Uh, we are just now getting into unnecessary deep multivariable calculus. Let's try anyway. So basically your Jacobian map is dou x by dou r to dou x by dou theta dou y by dou r into dou y by dou theta. This is equals to partial differential cos theta. Dou x by dou theta is minus r sin theta. Dou y by dou r is sin theta, and dou y by dou theta is r cos theta. So basically it is r cos square theta minus of minus r sin square theta. So this is nothing but r. So this is the main identity. If you want to change, okay, this 51 is becoming somewhat extra. It's creating some ruckus in the meeting. That okay. Okay, so basically you have this identity dx into dy equals mod of dou x by dou r into dou x by dou theta into dou x by dou y by dou r into dou y by dou theta into dr d theta. because this we computed as some r. This is nothing but r dr d theta. So this again, this goes into a unnecessary multivariable calculus thing right now, because that's beyond the scope of course. I just leave it to that. Anyone who is interested can look into some multivariable calculus and probe further. And also, I guess you have my contact number and can contact me for if you have any doubts or if you want to proceed. Okay. I guess this you can check for yourself. Just integrate 1 by t. It is basically log mod infinity minus log 1. So log infinity does not exist. So this does not exist and this does not exist. Okay, so now we just have to determine this value. And, this also kind of simple integration. Question 2. 1 to infinity t by t square plus 1 dt. So you define y is equals to okay. Is my screen visible? Sorry for asking it again. Y is
No, no, no. Not, not visible.
okay. Yeah, I hope it's visible now. Okay, so you define y is equals to t square plus 1 implies dy is equals to dy by 2 is equals to t dt. Implies your y will vary from what t approaches to 1, y goes to 2. This is anyway dy by 2 by y, right? So this is nothing but 1 by 2 integral 2 to infinity dy by y, which is basically 1 by 2 times log mod y from 2 to infinity. Does not exist, I guess. Yeah, it does not exist. Okay, I'm just skipping this question. Not that it's somewhat theoretical in nature, or else we'll come back to this question after a while. I don't know if anyone of you has done measure theory and stuff. You have done measure theory because I just want to go to Laplace transforms. We didn't. We have been checking on integrability and stuff and didn't do anything about Laplace transforms. So we'll just get to this. Okay. Now I'll go to question 4. What question 4 basically asks is us to find the Laplace transform of e power t square. Does this exist or not? So definition of Laplace transform f of s is basically Laplace transform of f of t is basically given by this particular map integral 0 to infinity f of t into e power minus st dt, right? So implies, see, for Laplace transform to exist, there's a condition that mod f of t must be basically bounded by some m e power alpha t, where a alpha is some scalar. So you can define a particular domain and everything. But now say you have integral 0 to t e power t square into e power minus st dt. For this actually to exist, uh, your t square minus st should be uh, basically less than 0. Implies, uh, I mean, basically you don't have any e power st for any value of s such that e power t square is less than e power s, e power minus st. Sorry, e power t square into e power st goes to 0. मतलब you can't upper bound it by some exponential function, because for say you take some e power s to be 1 or something like I'll just give two examples. Yeah, so you take e power 2t and we have e power t square. So you multiply by e power minus st and say for s greater than 2, you can find this Riemann integral. I mean, you will find integral 0 to e power st and can find some Laplace transform. But for e power t square, for no, you take any constant value of s, you can't you can't bound e power t square. So your Laplace transform will not exist for e power t square. Yeah, it doesn't possess a Laplace transform. So in fifth question, I don't understand. So your t power n is always bounded by some e power st. So both of them are actually 0. Yeah, okay, this is t tends to 0 and this is t tends to infinity. Exponential function always uh, dominates any polynomial function. So this goes to 0 and anyway at 0 it's this goes to 1 and this is 0. Again, this is something I'm telling in a hand waving method, but there is some robust analysis that has to be done. This, I think, beyond the scope of. Okay, let us find e power 3t. So I guess right now we are entering to the Laplace domain. This is question number 6. Just find Laplace transform of e power 3t. So this is the Laplace transform of f of t, uh, which is defined by some f of s, which is equals to integral 0 to infinity e power minus st into f of t dt. Okay, so e power 3t integral 0 to infinity e power minus st into e power 3t dt, which is nothing but integral 0 to infinity e power 3 minus s into t dt, which is e power 3 minus s into t by 3 minus s whole into 0 to infinity. So see, for so you have e power 3 minus s, here t is going to infinity by 3 minus s minus 1, minus of 1 into 3 minus s. So for this limit to make sense, 3 minus s has to be less than 0, implies your s has to be greater than 3. Only for s greater than 3, this integral will make sense. So this is minus of 3 minus s, which is nothing but 1 by s minus 3. So if this were t square, we won't be finding such domain actually. We won't have, for any value of s, the integral won't be bounded. Now we have using the Okay, so f of t is 0 for 0 to 1 and t minus 1 for t greater than 1. We have to find the Laplace transform. So I'll just do it in two ways. One using normal definition, another using an identity. Is Laplace transform of f of t minus a equals e power minus as f of s, where f of s is the Laplace transform of f of t. This is one direct identity, but let me check. I'll prove that identity and we'll go. Okay, what do we have here? So basically the function f of t is 0 from 0 to t less than 1 and t minus 1 from 1 to t plus infinity. So this is nothing but e power minus a into 1 into Laplace transform of t, which is e power minus a into 1 by s square. So this is an estimate. I mean, we'll just look into that. So let us prove it. Let us compute this via definition. So what is Laplace of f of t? Laplace of f of t is integral 0 to infinity e power minus st into f of t dt. So which is nothing but integral 1 to infinity into t minus 1 into e power minus st dt. You can define t minus 1 is equals to some lambda. Uh, so that's how we get this identity too. So t minus 1 if you define as lambda, so this is 0 to infinity lambda e power minus s into t is lambda plus 1 into dt is d lambda anyway. This is just change of integration. E power minus s, you take it outside, integral 0 to infinity lambda e power minus s lambda d lambda. So I'll just so this is e power minus s into integral 0 to infinity lambda e power minus s lambda d lambda, right? Which you can e power minus s lambda e power minus yeah, you know the Laplace transform of this. So it's basically 1 by s square, right? This is a Laplace transform of s, Laplace transform of t, sorry. So this is minus s into 1 by s. Okay. Now what? Just a second. Just checking if notes. I couldn't save the notes last time. Sorry, it's just taking. There's a glitch or something. No, here. I hope the notes are there. Just a second. Sorry for the inconvenience. I don't know why my MS whiteboard is not working. Yeah. Okay. 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 Yeah, I think almost everything is saved except for the last thing. So I have to share the screen. Okay. We are going to the next question. Eighth, this is direct identity. Laplace transform of t power k is basically gamma of k plus 1 by is power k plus 1. I guess please just check it on your own. I'm not solving anything because we have just 20 minutes and lots of questions. And, okay. Laplace transform of e power 3t sin t.
Sir, excuse me.
Yeah, yeah.
Not visible the screen, sir.
Screen
Not
is?
visible. No, sir. Screen
Okay,
not
okay.
visible.
Okay, okay. I'll just stop
Screen.
here. Is it visible right now? Is it visible right now?
No, sir. No, no.
Yeah, it is visible.
Yeah. So Nandini ji, can you just recheck? I think it should be visible. Okay, so we have.
My screen is not visible, sir. Okay, sir. I will check.
Yeah, you can just exit and just
Just
rejoin.
pin on Egna. Pin on
What?
Egna, right?
Yes, yes.
Egna.
Yeah.
Just tell her to pin on Egna.
Pin her.
And
What?
Egna is presenting, right? So
Yeah,
if she just pin the screen, it will come to visible.
yeah. Can you do that? Can you just pin the screen? I don't understand. Is it visible for everyone, or how many of you are facing the problem? Is anyone else not able to see the screen? Then just if you are not able to see the screen, just type it in the chat box. Okay, so I'm assuming that everybody is able to see the screen. Okay, okay. Sorry for the inconvenience. Okay, so we'll proceed then. So we have e power 3t sin t, right? I don't know what's the question, but Laplace transform of e power 3t sin t. So let me solve many things in this question. So I will first of all tell the method to compute Laplace transform of sin t and then Laplace transform of e power alpha t into some f of t, and combining these two we'll just try to compute this particular Laplace transform. So Laplace transform of uh, okay, I'm assuming that everybody is able to see the screen. If anyone is not able to see the screen, please type I'm not able, this screen not visible in chat box or something like that. Okay, anyway, I guess YouTube video will be made available to you, so you can always check that if you have missed anything. Okay. So Laplace of sine alpha t, I'll just uh, derive in general. Or should I? Okay, I'll just. So Laplace transform of sine alpha t, I'll just take that to beta. Implies integral 0 to infinity e power minus st into uh, sine beta t dt which is nothing but imaginary part of integral 0 to infinity e power minus st into e power I beta t, right? There'll be an integral. So this is nothing but imaginary part of integral 0 to infinity e power beta minus s into t, I beta into s minus t dt, which is basically imaginary part of e power I beta minus s into t by I beta minus s in the limit 0 to infinity. You just take s to be a real complex value such that it's very large, so at infinity it will become 0, which is nothing but imaginary part of minus 1 by I beta minus s implies Laplace of sine of beta t equals imaginary part of minus 1 by I beta minus s. It's nothing but just multiply and divide by so this is s minus I beta. You multiply and divide by imaginary part of s plus I beta by s square plus beta square. So you take the imaginary part of this. If you take the real part, it becomes Laplace transform of cos x. So this is how you land up with Laplace of sine beta t to be beta by s square plus beta square. So we'll just remember this identity for a while, and then let me derive one more identity. Say if Laplace of f of t, which is equals to f of s, say, which is basically 0 to infinity e power minus st f of t dt, right? Then what will happen if you have Laplace transform of e power alpha t into f of t, which is basically what integral 0 to infinity e power alpha t into f of t into e power minus st dt, right? So now you take integral 0 to infinity f of t into e power minus of s minus alpha into t dt. So if f of s is basically integral 0 to infinity e power minus st f of t, then what will integral 0 to infinity e power minus s minus alpha times f of t dt be? This will be f of s minus alpha, right?
Of s minus I.
Yeah, f of s minus alpha. So
Sorry, sir. F of x minus alpha.
yeah, okay. So now that's how we just solve this. So we have Laplace transform of sine beta, and we are just multiplying by. So we have beta is equals to 1 and alpha is equals to what, 3, right? So this is 1 by s minus 3 whole square plus 1. Just combining the identities.
Sir, is this identity is called first shifting theorem of Laplace transform?
I didn't get you. Can you just repeat?
Yes.
Yeah. Can you repeat? Sorry.
Sir,
Yeah.
sir,
Yeah, it
L
is
of
called
e
first
raised to
shifting property.
Yeah.
first shifting theorem. Is this one is called first shifting theorem of Laplace transform?
Yeah. Yeah. Yes.
Yeah, of course. That is,
Yes. The property
sir,
is called that.
and in the derivation of sin L of sin alpha t, if we use the identity integral 0 to infinity e raised to 8t sin A alpha plus B t dt equal to, there is an identity, such an identity.
Yeah, you can directly use that. I just yes, there is an identity for that. I just did it in a different way so that I could
Okay,
compute
I
two
think it's
different concepts.
if we applying the imaginary part of such a way, I think it is difficult for me. That's why I asked such a question.
Okay, okay.
Okay, sir,
You
thank
can,
you.
Sir, hello.
yeah, you can, yeah.
Sir, in the method you have written sine beta as e to the power I beta t.
Yeah,
But here the domain of convergence is s should be less than I beta. So domain of convergence also include complex number.
yeah. So basically, I have been kind of, you have caught me. So I have been kind of careless with the domain. So it is basically power 3t into e power it, right? Something like that. Let us say e power uh, 3 times uh, 3 plus I t. So your S has, so you have to take a complex domain I, it's a complex domain, and say this is minus 3. This is minus 3. Your domain will be entire complex plane with all the real part of S less than minus 3. So real part of S should be less than minus 3. Sorry, it has to be greater than 3. Sorry. Real part of S has to be greater than 3.
Yeah, for that reason, you can define what is the value of beta. There will be a particular condition for beta, right? Sin beta.
Yeah, for beta, there will be no condition, right? It will be just real part of S less than 3. That's it. For beta,
For s there will be a condition like
yeah, yeah. So see, just check. So basically, here S greater than 3, it's just that it's real part of S. S is in complex domain, but S has real part of S has to be greater than 3. That's it.
okay, sir.
Yeah. Okay. So now we'll go to the next question. I guess else we have 5 minutes remaining. Should I try some OD related questions? Okay, let us do 10 and 11 and call it for the day, I guess. Okay, so this is Laplace transform of 5 times e power minus 70 plus t plus 2 e power 2 e power
Yeah.
2. So yeah, you can write it directly s plus 7 plus m by v square plus 2 by s minus 2. Only thing is you have to be careful with the domain. S, so this is minus 7, this is 2. So for this term to for Laplace transform of this term to exist, s has to be greater than minus 7. For t, it can be, I mean, it will exist anyway for any s greater than 0. This I'll use some other color. For t, it will be basically t has to be greater than 0. That's it. Okay, what is the reason for which the domain of s has to be greater than 0 for t? So integral 0 to infinity t e power minus st, right? So 0 to infinity t d by dt of e power minus s by minus s dt, which is nothing but t e power minus st by minus s minus integral e power minus st by minus s into 1. This is this chain of, change of order of integration by parts. So for t power minus st by minus s, 0 to infinity, at 0 it will exist, no doubt. For what? For t power minus st to exist at t, if t goes to infinity, for t power minus st to make sense, your s has to be greater than 0. It cannot even be 0. Right. So t power even minus 0.001 t, even if t goes to infinity, this value goes to 0. So your s has to be greater than 0 for this. And for s minus, for e power 2t, again, yeah. For again e power 2t, it's this domain. Right. Okay. So you just take the intersection of all the three domains for it to exist. So for s, for real part of s greater than 2, this particular thing makes sense. Let's try one last question. Laplace transform. This you can try. Just trying. Okay, let us try this one. G of t is e power at f of t by b. I think we'll be covering even the previous question with this. So we have g of t is equals to e power at f of t by b. T by b, we have to find Laplace transform of g of t. If Laplace transform of f of t is f of s, I guess that is the main. So Laplace of g of t, sorry, t, which is nothing but g of s, which is basically Laplace of power at f of t by b, right? Which is nothing but integral 0 to infinity e power at of t by b to e power minus st dt. Okay. So let t by b is equals to some lambda plus integral 0 to t is e power ab lambda into of lambda. Okay, okay. So here something should we take? So should we take this one? Okay, let us take t by b is equal to lambda f of lambda e power minus same thing lambda b b t is b times lambda, but b times integral 0 to infinity f of lambda into e power minus of sb minus ba. This doesn't make sense. Just a second. I think we have to transform f of d by b into power minus s minus a into t dt. Okay, now we just substitute t by b. Any ideas on how do we find the Laplace transform structure? E power 18 of
You can just consider as it is the definition uh, by just replacing f of t by the definition says that e power minus st into f of t dt, right? So
yeah,
we can as g of t is defined as e power 18 into f of t by t f of t by b.
okay,
So you can consider e power minus st as it is, and f of t will be replaced by f of t by a t by b. Finally, you can replace s by minus a by minus s. You will get the answer.
okay. Just let me check. Okay, let's wait. Let's do step by step. Yeah, I get what you're saying. Just check. Or else, I guess let us end the session for today. I'll begin next session with this question. Yeah, it's 4 by now. Okay, fine. Thank you all for your participation. Yeah, I guess today's participation was better than last week's thing. Sorry, I couldn't complete all and I got stuck at this point. Let's begin with this question from next class.
But I felt bad. This time you admitted everyone in between. But I waited for more than 45 minutes in the last week. You didn't admit me.
Sorry. I guess this is the first time that I'm dealing with 60 students and so on.
Yeah, last time I waited for 45 minutes.
Yeah, no. So although I say that I won't admit anyone after 10 minutes, I keep on admitting people. Maybe
But I
in between
didn't
all the
get
notifications,
admitted.
maybe I have missed
It's
your
okay. It's okay.
invite.
No issues.
Yeah,
No
yeah.
issues. No problem.
Sorry for that.
Okay.
Okay.
Thank you. It was a nice session.
Yeah. Thank you all for attending and sorry, the last question I got a little bit stuck and kind of I think I need tea or something.
Nothing there. You
Yeah,
can
yeah,
just you can consider as it is the problem.
yeah.
You can finally replace s by just change the parameter as the parameter is should be s, right? So we can the constant will be replaced a. We can just replace s by minus a. That's all you are going to get the answer. I'm thinking like that. You will get the answer like that.
Yeah, let's check. I mean, yeah, I'm not. Yeah, let's do this next time and yeah, I'll sure look into that. Okay, if you don't have any doubts, you're free to leave. Yes, we have more 2 sessions and assignments that we have. Assignment. Yeah, if you don't have any doubts, you can leave. Yeah, I'll just stay for
When
that.
you are going to
Yeah,
discuss assignment two,
yeah. I guess next week I'll discuss. I'll
someone
just
asked in regarding assignment two.
yeah. Okay.
Chat
Yeah, I'll discuss
chat box.
assignment two.
Somebody asked
Next week.
regarding assignment two, question number three.
Yeah, I'll discuss it in the next week. Actually, we have 2 more classes. I'm thinking, should we do? Yeah, I'll see what can. assignment. Question 4 and yeah, we'll try it next time. Push assignment 2 appears to be interesting. Let's see what's in assignment. Yeah, we'll do assignment 2 next time. I guess I'll stop recording.